Hi, in this video, we are going to solve one question from exercise 5.6. That's question 20. It's related to substitution methods, I guess. Okay. The question is, we are given two functions, x equals y squared and x equals y plus 2. The question is, we need to find the area enclosed by the graphs of these two functions. Okay, first, if we sketch this, suppose that this one is our x-axis and that is our y-axis. Let's say it is y, it is x, because as you see here, x is expressed in terms of y. That's why it doesn't matter how you are actually constructing your coordinate system, right? So for me, let's say this vertical actual line, I just label this by x and the horizontal line by y. So actually, we are familiar with this function. The first one, x equals y squared, is a parabola. Parabola is something like this. That is the function, the graph of the first function. And the second one is y is equal to 2, right? So when y is equal to 0, right, that's equal to 2, or when y is equal to -2, that's equal to 0, somehow actually it will actually cross here. So it will be something like this. So the question is, what is the area enclosed by these two functions? Okay, let me just write here. That is x is equal to y plus 2. And this function is given by this equation. X is equal to y squared. So first we have to find the intersection points, integration limits, right? And let's say this A and this one is B. To do this one, in the first step, we have to solve this equation that y plus 2 is equal to y squared, or y squared minus y minus 2, that's equal to 0. Now we can solve this quadratic equation by factorization. Here we have y plus 1 times y minus 2, that's equal to 0. So the first root of this equation is y equals -1, and the second root is 2, which means that actually a is -1 and b is 2. Okay, that's the first part. And the second part is, how do I know that actually I should subtract actually this parabola equation from the straight line or not. Actually, when you're forming this, right, if you draw a line parallel to the x-axis here, if I draw here, actually this serves as a height of our rectangle, right? And how do you find the distance between 2 points on the y-axis if you're given a vertical line? Let's say we're talking about 2 points. Let's say this one is y1 and this one is y2, right? What is the distance between these 2 points? The distance is equal to y1 minus y2. How do I know that? Because y is located above this y2, right? Because I'm sure that y1 is greater than y2. And that's why this difference gives us positive. So I don't have to put an absolute value. So at the time, this area, this shaded region, let's say this area, will be called the integral, and that is from -1 to 2, -1 to 2, right? And I have to subtract actually this parabola from the straight line. The straight line's equation is y plus 2 minus, and parabola's equation is y squared. And here we have dy. So now if you integrate this, that is 1 over 2 y squared plus 2y minus 1 over 3 y cubed from -1 to 2, which is equal to, when it is 2, we have 4 over 2, that is 2, plus 4 minus 8 over 3, minus, when is -1 square over 2, that is 1 over 2, minus 2, and plus 1 over 3, right? So now if you simplify this, that's equal to 2 plus 4, it is 6, and 6 minus 8 over 3, minus, and here we have, okay, 1 over 2 plus 1 over 3, that is 5 over 6, 5 over 6 plus 2. All right. So now, whole part, 6 plus 2, it is 8, minus, and the common denominator is 6. 2 times 8 is 16. 16 plus 5 is 21, right? or 6 times 8, 48. 48 minus 21 is 27. So that's 27 over 6. And so we can simplify this further. Divide by 3, it is 9. Divide by 3, it is 2. Or the answer is 4 and a half units squared.